Alright, so we have a circular arc of a railroad curve has a chord length of 3,000 feet. So this would be 3,000 feet here. And it has a central angle of 40 degrees, so our 40 degrees is down here. Okay. We want to find the length of the radius and the length of the arc. Well, in order to find arc length, we need to have that radius first, so that's going to be what I try and find first. To do that, I'm going to take this triangle that I see and I'm going to cut it in half like this. What that does for us is create a nice little right triangle here where the base would be 1500 and this angle measure would be 20 degrees. And here's our right angle. So since I have an angle, its opposite side, and the hypotenuse, that sounds like sine. And that's what I would use, is the sine of 20 degrees is equal to opposite over hypotenuse. So a little bit of algebra says R is 1500 over the sine of 20 degrees. So grab your calculator, calculate that. Then for the second part where we have to find arc length, we do have this formula. Arc length is radius times theta, with this little caveat that theta has to be measured in radians. So I always say radius times radians. Well, we just figured out our radius from up above, that 1500 over the sine of 20 degrees. So whatever value you get for that, times theta. But theta has to be measured in radians. So real quickly, we think 20 degrees. If I want to turn that into radians, I have to multiply it by pi over 180 degrees, which looks like pi over 9 to me. So calculate that, and you should have your arc length.